Thank you, viewers and learners, for staying tuned to this lesson on matrices, that is the determinant and the inverse of a matrix. Now, in this particular lesson, you have to look at how do we find the determinant and the inverse of a matrix. Now, how do you find the determinant of a matrix? That is the first thing you have to look at. Now, given any matrix A, B, C, D, I'd like us to be a privy of the letters A, D, and the letters C, B, depending on the color they have been represented with. Now, despite a matrix being defined by the number of rows and the number of columns, a matrix also has diagonals. Now, we have those elements that are in this diagonal, that is A and D, and this diagonal is known as the leading diagonal. Sometimes we call it the principal diagonal, the main diagonal, or the primary diagonals. Then you have elements C and B, and these one are found in the second diagonal that we call the secondary diagonal. Now, this is a 2 by 2 matrix. So at this particular stage, you'll learn how to find the determinant of a 2 by 2 matrix. That is also a way of finding the determinant of a 3 by 3 matrix. Now, how do you find the determinant of this matrix now? Now, the determinant is equal to the product of elements in the leading diagonal, that is A and D. From it, you subtract the product of elements in the secondary diagonal, that is C and D. By product, we mean multiplication. So this one becomes A multiplied by D. From it, you subtract C multiplied by B. And that is how you find the determinant of a matrix. Now, for example, determine the determinant of the matrices below. We have this matrix 3, 4, and 2, 5. They want us to determine the determinant. Now you can see that the primary or the leading diagonal has numbers 3 and 5. Then the secondary one has numbers 2 and 4, even from the colors. So the determinant is going to be 3 multiplied by 5. From it, you subtract 2 multiplied by 4. And this one is going to give us 7. So the determinant of this matrix is 7. Another example, 2, 3, negative 3, 7. So how do you define the determinant of this one? That is going to be 2 multiplied by 7. From it to subtract negative 3 multiplied by 3. And this one is going to give us 23. Can look at another example, that is 2, 3, 4, 6. And the determinant of this is 2 multiplied by 6. From it to subtract 4 multiplied by 3. And this one is going to give us a determinant of 0. There is something I want us to note, and that when the determinant of any matrix is 0, then the matrix is called a singular matrix. When the determinant of any matrix, like the third one here, is 0, that matrix is known as a singular matrix. A singular matrix is a matrix that has a determinant of 0. Now, we've looked at the determinant. Now, I want us to look at the inverse. How do we find the inverse of a matrix? And that is a 2 by 2 matrix. Now, first of all, I want us to look at a question that says determine the inverse of the matrix A below. So the matrix is 3, 4, 2, 5. That is the matrix that you have to determine its inverse. Now, for us to determine the inverse of a matrix, the first thing for us to do is to find the determinant. So we need to find the determinant of this matrix, and the determinant here is going to be 3 multiplied by 5. From it to subtract 2 multiplied by 4, and this one is going to give us 7, because 3 times 5 is 15, 2 times 4 is 8. Subtract, you get 7. Then after this, what do? You interchange the elements in the main diagonal, that is the elements in the main diagonal or the leading diagonal, that is 3 and 5, and reverse the signs of the elements in the secondary diagonal. What do I mean by this? I mean the elements in the leading diagonal are interchanged, that is 3 and 5. So you interchange them. After you interchange them, the elements in the secondary diagonal, you negate, you change, or you reverse the signs. So 2 and 4, all of them are positive. So you reverse the sign, they become negative, all of them. So you have -2, -4. Now, after this, you have a new matrix. So you have to take the matrix obtained and you divide it by the determinant. So what do we mean? Take the matrix obtained after reversing and interchanging. So you have 5, -4, -2, and 3. So you divide it with the determinant. We divide the determinant. 5, each element is divided by the determinant. 5 divided by 7, -4 divided by 7, -2 divided by 7, and 3 divided by 7. And this one translates to finding the inverse of that matrix, which can be written A to the inverse. And this one translates to 5/7, -4/7, -2/7, and 3/7. So those are the steps that are followed in determining the inverse of a matrix. Now, I'd like us to note something. When the determinant of a matrix, just like we said, when the determinant of a matrix equals to 0, then the matrix has no inverse. And remember we said a matrix whose determinant is 0 is called a singular matrix. So a singular matrix has no inverse because the determinant is 0. The determinant of that matrix is 0. Now, practice exercise. Determine the inverse of the following matrices where possible. The first matrix is 4, 9, 2, 5. Determine its matrix. The second one is 8, -4, -3, 2. The third one is a half, a sixth, 6, and 2. So try to determine the inverse of the matrices below. Mark Q. For you to determine the inverse of a matrix, first of all, you need to determine the determinant. Then after you've determined the determinant, you reverse the elements. I mean, you interchange the elements in the leading diagonal. Then the elements in the secondary diagonal, you reverse the signs for that. Thank you for watching and learning. You can like and subscribe to my YouTube channel, Ombisi Online Math, Facebook, Ombisi Online Math. Thank you.